Hello everyone, my name is Kimberly Kim Brown, and this presentation delves into the background of AsteroidOS, its core components, and the impact of various abstractions and services on the programming environment. Here is my table of contents and things that I will be discussing during this presentation. I will be briefly going over the introductions, a background on into AsteroidOS, its core components, unnecessary components that I feel like are as important but are take a more of a backseat in comparison to the other core components, and impact, or if there is any impact on the programming environment, and then I will move directly into my conclusion. Introduction. What is AsteroidOS? AsteroidOS is an open source operating system designed for smartwatches as a firmware replacement for some Asteroid wearable devices. It provides a platform for developers to create applications tailored to wearable devices, unique features and constraints. The background. AsteroidOS emerged in response to the growing demand for an open source alternative to proprietary smartwatches operating systems, conceived by a community of developers passionate about wearable technology. AsteroidOS was born out of the desire to offer greater freedom and customization options to users and developers alike. Its development began in 2014 as an ambitious project aiming to provide a lightweight, efficient, and customizable operating system specifically tailored to the constraints and unique requirements of smartwatches. Unlike main platforms such as Wear OS or watchOS, which are tightly controlled by large corporations, AsteroidOS embodies the principle of open source software, fostering collaboration and innovation and transparency within its community. Since its inception, AsteroidOS has evolved from a small-scale initiative into a mature and feature-rich operating system with a dedicated user base and active development community. With its commitment to openness, flexibility, and user empowerment, AsteroidOS has gained recognition as a viable alternative for individuals seeking a greater control over their wearable devices. Now let's briefly talk on some of the core components of AsteroidOS and how it adds to the operating system as a whole. Processes. AsteroidOS manages processes through a robust system that governs process creation, termination, and scheduling. When a process is initiated, the operating system allocates resources and assigns it a unique identifier. It's inter-processes communication and synchronization. AsteroidOS supports IPC through message passing, shared memory, and sockets. Synchronization mechanisms such as semaphores and mutexes and condition variables ensure orderly access to shared resources, preventing race conditions and data corruption in concurrent operations. Semaphore is basically a signaling mechanism that allows multiple threads to coordinate access to a shared resource, while a mutex does the same thing, but it only allows for one thread to that shared resource. Memory management. AsteroidOS employs dynamic memory allocation techniques to manage system memory efficiently. The operating systems allocate memory to processes as needed and deallocates it when it is no longer in use. Memory management strategies include segmentation and paging, optimizing resource utilization while preventing memory fragmentation and memory leaks. Moving on to some of its more core components, file system and persistent storage. AsteroidOS utilizes the file systems such as x4 and F2FS to organize and manage data on smartwatches. These file systems support hierarchical directory structures and provides mechanisms for storing data persistently, ensuring data integrity and reliability even in the event of power loss or system failure. Its input and output. Input methods on AsteroidOS include touchscreen gestures, physical buttons, and voice commands, providing users with intuitive interactions options. Output capabilities encompass the display screen, haptic feedback, and audio output, delivering seamless user experiences across various smartwatch functionalities. Programming, loading, and unloading. Applications loaded onto AsteroidOS through package management systems or manual installation methods. The operating system dynamically loads and unloads programs based on user interaction and resource availability, optimizing memory usage and system performance. For some of the unneeded components, they are and they do fit the AsteroidOS, but it is more of a backseat compared to the other components, and this involves multiprocess support, network support, and graphics. While AsteroidOS is designed to support various processor architectures and configurations, it is kind of unnecessary. Multiprocess support may be unnecessary for devices with single-core processors, as they cannot take advantage of parallel processing capabilities. In such cases, the absence of support for multiprocessors does not hinder the functionality of the OS. Rather, it'll streamline the system's architecture and reduce complexity. Similarly, the network support may not be essential for standalone smartwatches designed primarily for offline use, such as fitness trackers or specialized medical devices. In these instances, omniting network-related functionalities can simplify the OS and reduce power consumption, as there is really no need for constant network connectivity. Additionally, sophisticated graphics rendering capabilities may not be necessary for minimalistic applications that display basic functions such as notifications or timekeeping. Components of AsteroidOS profoundly shape the programming environment for developers targeting soft smartwatches. These components comprise various aspects that developers need to understand how AsteroidOS handles processes, memories, and files to optimize resources and usage efficiently. Familiarity with inter-process communication and synchronization mechanisms is essential for building collaborative applications, while knowledge of input and output methods facilitates the creation of user-friendly interfaces. In conclusion, AsteroidOS presents a comprehensive platform for smartwatch development, offering a rich set of core components that profoundly impact the programming environment. From their many abstractions and services, AsteroidOS equips developers with the tools needed to create versatile and connected applications for smartwatches. By understanding and leveraging these components efficiently, developers can optimize resource utilization by enhancing the user experience and build robust and secure applications tailored to the unique constraints and opportunities for smartwatches. And that takes me to the end of my presentation. My next slide includes my references and everything I've used as a source throughout my paper, and that is it. Thank you for listening.